you. I got secrets that nobody knows.
Hello, hello. So today we are going to start with uh, again Accenture prep. This is going to be the third day in the series of my life preparation for Accenture. And today these are the targets. Let's see how many of these can we cover. We have still 3 hours, more than 3.5 hours for the day to end. Why was I so late? Why didn't I live stream earlier? Um, the major reason, the main reason was I have uh, an exam coming up, and I'm parallelly also preparing for it. So it took most of my that subject preparation took most of my time, but hopefully we can make up for the day in these remaining 3 hours. My target is to stream um, until I completely give up. Like when I'll not stop until I literally can't do any further. Okay, so I guess this media is still hindering me. This is a big problem. Always forget that sound is background music is getting played. Excuse me for a second. So um, so we have two tabs opened. Assume this is the one. I'll just quickly see if I am live. Yes, I am. What do I want to do? Check, check. I somehow got hell of views of on my last to last video. Not working now. Okay, so we'll start with coding question, the biggest and the hardest of all. Code and development questions. See, my priority is three coding questions definitely, and then development questions. And no matter what happens today, I'll practice psychometric and gamified questions. Okay, so let's see where we reach. Officially, the day day three started very late. Actually, this is the problem. Actually, yesterday was a yesterday was a very proud day for me because I managed to do a problem which I initially thought I wouldn't be able to. So continuing that spirit, let's just proceed. Count carry. Count carry problem. Okay, why not? Let's just start with the clocks here. So actually, I have a very close window attached to my room, so and I'm on the ground floor. A carry is a digit that is transferred to left if some of the digits exceed 9 while adding two numbers from right to left. This is normal addition they are telling about, one digit at a time. Correct. You're required to implement the following function: number of carries. Okay, number of carries. Wow, interesting question. So the function accepts two numbers, number one and two, as arguments. You have to calculate and return the total number of carries generated while adding. Oh, I'll why not use uh, this? Then you are required to calculate and return the total number of carries generated while adding digits of two numbers. Okay, assumption one and two are both greater than or equal to zero. Correct. Example this then. So if the addition of the last digits, correct, addition of the last digits is greater than 9, then we are going to increase the counter. Correct. I guess this is it. We'll figure out a solution right now. So quickly, I'll explain the problem. So we are taking two digits as 451, 349. 451 and 349. There can be a case when we have 999 here and we have simply one digit here. The second number is only one digit, and it can be uh, vice versa, or both can have multiple digits like 99 and uh, 347. Okay, so this can also be the case. There is nowhere given that both the numbers are of same length. Length in sense the number of digits are same. So how should we do it? So definitely from the last number we'll proceed, and we need to remember the carry, so that we can add into the second digit addition. Correct? Correct? No? What can be the logic for this? Now in this case, how many carries are getting? How many carries can we count? So one, correct? Then one, correct? How many carries do we count in this case? Three carries or two? How many carries do we count here? In this case, one, correct? One, two, and we have eight here. So two carries in this case, correct? Yes. Will this also be considered a carry? Yes, I guess. Yes. So three here, two here, and some here also. Let's take nine here. So we have 16, 15, one carry, and then I guess this will also be two, because there is no, this is not being used on top of another number. I need to clear this first, and we have another over here. So the answer must be 3 or 2. So this example is not helping us. Why not ask our friend GPT? Okay, so we give this question to our friend GPT. Let's see what he says. I have personified him as male because I have used his. Okay. Removed my hand. My viewers are requesting me to do it. Uh, so, okay, let's ask our friend GPT. Okay, studying. Thank you. So it turns out that we haven't clicked the screenshot. Let's Why are we doing this? Because we want the test cases, proper test cases. So, how many? Give me good test cases. Two are watching, you and me, because I am also watching myself. That counts. And give me like I have a 999, 999 one, and what was the other end? 99 947, 99 and 947. In these, how many carries will be counted? Three or two. Thank you for joining. Here are correct counts. Three counts. Okay. So three in this case and three in this case. Correct. So my doubt is cleared. So we have, so here we are going to have three test cases in both. So almost we were almost correct. Our assumption of taking it three was a good one. Now let's write the logic. What do we want? First we want the last element of both the numbers. Correct. So we take the last element from this number and the last element from this number, and we have a separate number that does that. We have a separate variable that does that for both of them. So till when should we do? Until the length, until the number becomes zero. Correct. Until the number becomes zero. Yes. While, so we have number one. Run till number one is greater than zero, and number two. I guess this is going to be the uh, conditional logic, the loop logic. So we are running it till here. Now what do? We take two pointers, correct? That will keep note of the end digits for both of the two. Let's assume like this is for number one and this is for number two, but I don't think this will help. What can we do? Let's try it. How do we extract the first digit of the first number? Okay. And digit of first. How do we do it? We do n1 mod 10. We get the last digit of the first number, correct? We get the last digit of the first number. Then we have the last digit of the first number, and we want and of 2 and digit of the second number, and 2 mod 10. So we have end digits of both the number. If if uh, if end 1 plus end 2 is greater than 9, count plus plus. Correct. Where are we declaring count? Keep these things for later, because oh, oh, it doesn't matter that if we are declaring count. This is just a assumption code. Correct. We have to create the logic. We are creating the logic here. And 1 and 2, and now we have to update the numbers. Now we have to update the numbers. Also, we do we have to check the addition? No, we don't have to give the addition of the two numbers. So we just have to count. Correct. If okay, so we update the two digits. How do we do that? Do that. N1 is equals to N1 slash 10, and this is outside if. Correct. And N2 is equals to N2 by 10. That is correct as well. Both number must be greater than 0. What if one number exceeds? What if let's use another color this time. Are we good? Yes. What if we have 29 here? Okay, so 9 gets cut. Now we have 2. Then let's assume we have 3 3 3 over here. 3 gets 2. Now we are left with 33. Correct. In the next iteration, we don't even have 2, and we have just 3 here. Okay, and next time does the loop run? So number 1 is, this condition is violated. Correct. Number 1 is not greater than 0 anymore. It is divided by 10, and what we get after division by 10? 0. So I think this is the code, and this is the ultimate solution. Do we have to code for this? Yes, we have to. Program is, let's see. Ah, int number 999, int 1 is equals to 999, number number 2. Is it the right syntax? 55. Is it the right syntax? We'll find out. Now we have to pass this system dot print and count carry counter. Okay, now here we are passing num1, num2. That is correct, and we are printing it. Now we copy the carry counter and we write public public static int main, int we should int num n1, int That is correct. Why do we do that? Why did we do that? We have updated also. Everything works fine. And do we have to see for the edge cases, like if number are both numbers are zero, then also answer will. This will still work fine. So how many carries should we see? Three carries. We will be seeing three carries. Okay, so the answer must be three. If we haven't made any mistakes, answer. Oh, this is the first time that I've written the code, and this is flawless. This is flawless. Let's do 9. How come 3 carry over still? How many carry overs now? 1, 2, 3, 4, 5, 6 carry overs. Huh? Okay, so this logic is not correct. Yes, because it won't run if the number is 0, even if we have to count. So we have to compute the result also, correct? Good that we found out. If it is greater than this, correct? I think the while must not stop. Mm, so what problem are we facing? Okay, I'll tell you. See, with this logic, if let's say we have 999 plus 1, then with this logic, we only the sum must be this, correct? But with this logic, see, if we add this, and this is let's say n1, and this is n2, that is 1, correct? And now after first iteration, this value will be updated and this value will be 0, correct? The second time the loop will not run, so there is not going to be any count added. So even if we are having three more carries, it is counting only one. So this is the problem. How do we solve this? How do we solve this? Why don't we, what do we actually want? If so first of all, we have to stop this from ending, even if So this is definitely not right. I'll just keep it or for the time being. Until both are 0, it would stop. Okay, so we are updating, no? Okay, if we take the example of 10, then it will go one time. So 1 will be stored here. Any one? No, this is correct. What are we mistaking? Sum and digit. Huh? Only why? Digit, digit, digit. Have we actually done this? I don't believe. I don't believe. How many nines are there? Five, nine, and one. Nine, 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 nine plus one. Carries count. Okay. One, two, three, four, five. Correct. How many carries do we have? Five carries. Five must be the output. How many carries do we must we have in if I still not don't believe that I've actually done this. 347 plus 99. What must be the answer? One carry, two carry, one carry, two carry. So how many carries must be there? Ah, three carries, correct? One, correct. In place of here, one in place of here. Ah. It means I can solve questions. This was a good one. Good job, Shashank. And thank you for all this cheering. Somehow I did this question. I even myself don't know how I did it. Because see, here we were writing the wrong condition. But here we wrote the correct condition. We know that only if both elements will be 0, then we will compute to 0. Then we will only stop the loop. And this is such a complex logic. This is such a complex logic. I mean, to me, it's a complex logic. See, carry must come here, correct? And then it must be greater than, and then only then three conditions will work. We have to extract the first digit of this now. Then we are divided by 10, and we are getting here. Now we are getting carry, and we know that we have to add carry over here and some digit, and then we are stop. So this is a question that I want to practice afterwards also. I want to revise this. I'll use a green pen and we'll write in the thickest of shades. This is what we did without even seeing the solution. Correct use of or, correct. But we are not taking some outside. We have taken some inside only, inside the while loop. Taking some outside is better, I agree, because here we are initializing so many sums inside the while loop, and we are here only declaring it one time, and uh, that value is updated instead of creating new integers every time in the memory. So this is a bit I don't think this will make much difference, but uh, from a real uh, uh, on an honest answer would be that this keeping simple sum outside some integer outside the loop does makes a difference. So yeah, I'll quickly paste the code. Good start. Okay, so we have earlier done the question. We have earlier done the question which was binary to decimal, and this one is decimal to binary. Decimal to binary. Now this is decimal and we have to convert it into binary. How do we do it? Let's just think quickly. And how much time did we take in this question? Nearly 40 minutes. That's not appropriate, but uh, 40 will also be fine, to be really honest, because uh, no, actually, it is not fine. But see, we are going to have 60 minutes, and those 60 minutes, if I take 40 minutes for code, so I am left with 20 minutes for dev question plus SQL. SQL, I have to be super duper quick in completing SQL. Then only it will all make sense. Then only I will be able to compensate. So how do we do it? 10. Correct. So we divide 10 by 2. Divide 10 by 2. How this thing came dividing 10 by 2? I don't know. This just suddenly popped up in my head. Dividing 10 by 2 will give us 5. Then still we'll divide it by 2 and we'll get 3. No, we'll get 2. My bad. We'll get 2. We have to divide 2. This will give us 1. Okay. Okay. Understood. So it is not working with dividing. It will work with modulo. We have 10 here. Okay. What we do, we take 2 and then divide, no? Then we have 5. So there is no remainder left. Correct. Let's keep this sign as this. So we have, how much remainder do we have? 0. Now how much remainder do we have here? 1. What remainder do we have here? 0. Then what we are left with? 1 here. So 2 again last divided by 1 will give us a 0, correct? So here we have the answer. Here we have the answer. 0 1 0 1. But we have to read it from backside. So we are having 1010, which is the decimal of 10. How do we write the code? How do we write the code for this? Hmm. Ooh. With 2, there are only going to be two types of remainders, 0 or 1. That is so true. So this is what we'll do. We'll have a number x and we'll divide it, we'll mod it by 2. Whatever we are left with, we'll store it. Okay, so 0 1 0 1. In case of what? In case of 10, correct? This was the thing. uh, then we have to store it. Okay, store. So this new digit comes here. Mm, so we are getting 0 initially, correct? We are having 0 initially. We are having 0 initially, and this 0 needs to be shifted here. Then 1 will come here. Mhm. Okay, so n into 10 plus store. This is how we are going to store it. Okay, so we have completed the logic. Let's take let's remove these. Decimal to binary, no, decimal, we'll have 10. Okay, we'll write binary. Then we'll see what the binary comes, correct? Can you? Yeah, I don't feel good removing this code. I was so proud of it. I am so proud of it. Nice stickers. Kindly excuse me. I'll be right back.
secret that nobody knows. I'm fucked up, I'm black and blue. I'm built for all the abuse. I got secrets that nobody knows. I'm fucked up, I'm black and blue. I'm built for all the abuse. I got secrets that nobody knows. I'm fucked up, I'm black and blue. I'm built for all the abuse. I got secrets that nobody knows.
Hello, hello, hello. I am back. Sorry, there are some things which you can't avoid, and you must not avoid. Hmm, public static binary int and what we have to do. Okay, so what we were essentially doing, we were picking out, we were dividing by 2 ultimately, correct? While w- while so we need only while n is greater than 0.
I'm fucked up, I'm black and blue. I'm built for all the abuse. I got secrets that nobody knows. I'm fucked up, I'm black and blue. I'm built for all the abuse. I got secrets that nobody knows. I'm fucked up, I'm black and blue. I'm built for all the abuse. I got secrets that nobody.
So here we are, and we are getting 20. I don't know how. So let's figure out. Hmm, perfect. Binary. We are working binary as 0. Correct. I think this is the problem. So we are having the first number, and we are directly storing it as into 10. Is it a problem? Is it not? Let's decode it. So let's say if we have number 10, what will happen if this takes place? We number is the number that we get is the end digit, the modulus after dividing by n, that is 5. Correct. We have 5. Shit. So we have 5 here. Now we're doing 5 into 10. This is definitely not what. Oh, so my bad, my bad, my bad. We will not get 5. We will get either 1 or 2. Correct. So the remainder will be 0. We'll get 0 over here. 0 will be 0. And 5 will turn into uh, 10 will turn into 5. Then 5, this will be 1. Then 10, this correct. then 5 will be 2. Okay, it's a binary will be 10. 10 plus 10 20. Okay, I have sorted the problem. One solution is storing it into as character and then returning it as character and then changing it and then returning as character. This is one solution. So we can create a string over here for the correct answer. I'll use a small break.